Hello, my name is Sam. I'm with the Superfluid Developer Experience team, and today I'm going to walk through how to use the Superfluid SDK-Core to interact with the protocol using standard front-end technologies like JavaScript and Typescript. So you can find the Superfluid SDK-Core in npm or yarn here and install it. This walks through just kind of a comprehensive description of how the SDK works, how to initialize it, and how to use it. However, we have a step-by-step set of instructions inside of our docs as well. So you can come here to the interactive tutorial section. You'll see pretty much all of what we're going to go through today in written form with interactive sections of those docs as well. Here you can go through and figure out how to initialize the SDK depending on your preferred environment. And then in these other sections you can actually interact directly with what's going on. So we'll get started today with the money streaming section. Here what we do is we go through one of the cornerstone features of the protocol, which is being able to stream money. So here we walk through essentially the CRUD operations of working with money streams. We walk through creating, updating, and deleting. So if I open up one of these code sandboxes, we can see this in a bit more of a broad view. You can do the same as well on your own. And if we come to the create flow file, we can see how this is working. Inside of, I'll go back to config.js, we can see that I am storing an RPC URL here, and I'm also creating a new ethers.providers.json RPC provider and storing that in this variable. So we can use that when initializing the framework. That's going to be important for us with how we're actually going to end up doing this. And then here what we do is we go through a standard process of initializing the framework in a small React app, and then we'll go through and actually show you what the logic is for creating the flow. So to create the framework, right, to set it up, what you can do is use this await framework.create pattern, where you pass in the network name. In our case, this is the Coven testnet on Ethereum, and the provider, we're passing in that custom HTTP provider we just made. We then need to create a signer because we're using Ethers, right? It's kind of an Ethers native SDK. And we can do that by calling sf.createSigner, pass in our case, we're going to pass in a private key. Disclaimer, this private key has zero value associated with it. It's just all test tokens. Do not ever Disclaimer, this private key has zero valuable funds in it at all. It's just made for burner purposes. I'm giving you an example. Always either store this in an environment variable, never push it to GitHub, and ideally you'll probably also be working with this in a hard hat environment where you don't have to worry about this as much. So we create a signer like this by passing in a private key and a custom HTTP provider variable. We also store the address of DIX. If you ever need to get the address of a token contract, you can do that here for very popular tokens, right? So you can see we have things like super token DI or DIX listed here. Same thing with USDCX. And then in order to create the flow, this is a standard process here, but what we do is we run this. We create a new variable, which is effectively our transaction object, where we call sf.cfav1.createFlow and pass in these variables to open up the money stream. So we can pass in the sender of the stream, which is the address associated with our private key. We pass in a recipient, a flow rate, and then the address of the super token we're going to use. Then I have a nice little console log here to show the user what's happening in the console. And then if you want to actually broadcast this transaction to the network using the same process that I am, where you have a signer created, you can call createFlowOperation.exec and then pass in the signer. Here what I do is I just have a nice little console log again to show what actually happened behind the scenes. And then here at the bottom I have a bunch of React boilerplate, which is giving us this very simple application here. Okay, so if we enter an Ethereum address like this, and we enter a flow rate in wave per second, we can do that here. What we do for you is we calculate in this little React app what the flow rate actually ends up being on a monthly basis. As a reminder, flow rate is the amount of tokens you want to send in Way on a per second basis. This will equate to $25 a month. So if I click to create the stream, we'll be able to see this here. Excellent, we've created a stream. And if I go to the Superfluid Dashboard, we can see that a stream was opened for $25 per month, so we know that it worked. Now, the process for, if we go back into the money streaming section of the docs, the process for updating a flow is extremely similar, right? Where we just initialize the framework up here, create a signer, and then run the update flow operation, then sign the message with the .exec pattern. And deleting a flow is basically the same thing, except you just only need to, in your React app, pass in a single parameter, which is the address that you're deleting for. And the pattern is the same, with the exception of the fact that you don't need to enter in a flow rate if you're going to be deleting the flow. Okay? So that's creating, updating, deleting. Again, you can come here and read more about it if you like, but that's the high-level overview. Next, we need to go to the instant distribution section. So the instant distribution agreement, as a reminder, allows you to create an index and then distribute shares in that index to subscribers. And the first thing you need to do is create an index, then update the index by issuing shares to the subscribers, and then distributing funds to the entire index. Once you distribute funds, it will distribute that according to how many shares each individual subscriber owns. So if you have 100 shares outstanding and one subscriber has 10 shares, they'll receive 10% of whatever that distribution was, right? It's a great use case for recurring payments to a large group of individual accounts without having to spend gas on sending a new transaction to each individual recipient. So we have the same process here, where I'll open this code sandbox to show you what this looks like under the hood. We go to create index.js, and here all we're doing, this is a very simple component. All we're doing is we're just creating the index, right? So I'm generating a random number up here, and we're initializing the framework, creating our signer, adding the address of .x, which would be our token. And then just like we did for the CFA, we're going to do the same process with the IDA, where we create this operation, pass in the index ID, which is our random number, and the super token address, and then broadcast it to the network using this .exec with passing in the signer. So if we'll go back into the docs, actually this will be easier in here. If I click to create our index, it will do that for us here, so I can expand the console a bit. Alright, we now have an index ID that we can use. So once you've created the index, what you can do is pass in the index ID, a subscriber address, and the number of shares you'd like to give to the subscriber. So I got the address, we'll paste that in. We'll also need the index ID, which I can copy and paste from this first section, right here. And we need to enter a number of shares. I'm just going to issue 10 shares. We're going to click to update our index. Wonderful, we get a nice console log that shows that we did this. Let me go in here so you can see it. Wonderful. Same thing, same general pattern, right? We have things roughly working in the same format, where we are just, again, creating the operation, broadcasting that operation to the network. All right, so finally what we need to do is we need to distribute funds to our index. So I'm going to copy and paste in that index ID, and then I'm going to enter an amount to distribute in way. Let's distribute about that much. It's not going to be very much, right, because it's in way, but once again, we're calling distribute here. Expand a bit more. We have distribute, and then we're broadcasting that transaction to the network. Click to distribute funds, distributing funds to our subscribers. Fantastic. So we have done this. We've sent this many tokens to the index with this ID. If I go into the account, which just received this distribution, what I can do is take a look, and look at that. We just, at 0 days ago, today, we just received a distribution. Fantastic. Very small amount, but we can see that this worked. Okay, so that's the instant distribution agreement. The next thing that we want to discuss is how to use super tokens, right? So we assumed in those first two examples that you're familiar with what a super token is. You notice that we use .x instead of .die. .x, as a refresher, is super token It will allow you to use the ERC20 version of DAI within the Superfluid protocol. A super token is a special kind of token that you can use within Superfluid. It allows you to use them use tokens within agreements and things, send them around in IDAs, all that good stuff. You can create a native super token, which we do discuss here in the docs. A native super token is a token that's deployed directly as a super token. So there's no underlying ERC20 asset here. It's just directly a super token, right? It has all the functionality out of the box. Now, in order to make Superfluid interoperable with the rest of the ecosystem here, what we have is another special contract for wrapping ERC20 tokens as super tokens. So if I want to use DAI within the Superfluid protocol, I could, if I want to, deploy the ERC20 token wrapper contract, which will allow me to use DAI within the Superfluid protocol by wrapping and unwrapping those tokens. Fortunately, that contract has been deployed on most of the major networks that Superfluid is deployed on, like Coven, which is a test net, but what we're using today. And you'll be able to just call functions on that ERC20 wrapper contract that makes up DAIX to wrap your ERC20 tokens and then unwrap them when you want to redeem the underlying asset again. So there is code that's required to be able to do this if you want to allow this for your users, right? I can, if I want to, go to the Superfluid Dashboard to make this happen, right? Just in the currency section. We have a wrapper unwrap section here. But if I want to do this inside of like my own application for my own users, I'll need to write some custom functionality. So let me open this sandbox. And we'll see here that if I go to upgrade DAI, we have what this looks like. Again, in config.js, I'm doing the same process where I have this URL is put in here. I also have the ABI of DAI that I've included. In this component, what I'm doing is I'm allowing the user to approve the DAIX contract to spend our ERC20 DAI, right, just like we do in the rest of DeFi. And then we are going to run the upgrade logic down here, right? We're going to have to create the signer and do all that stuff that we've done with the Superfluid protocol already. So here in the DAI approve function, what we're doing is we're just approving the super token DAI contract, right? The address of DAIX, which you can find once again in the network directory. So we're just finding the address of DAIX, right? In this case, this is a different network you're seeing here, but this is the address of DAIX on Coven. We approve that, and then down here, what we do is we create the super token contract here by using this sf.loadSuperToken pattern. We pass in the address of the super token contract, and then we run the upgrade operation. Right, so we can see here, we're calling upgrade, we're passing in an amount to upgrade, and then we're broadcasting that to the network and providing a console log. So let's enter an amount we'd like to upgrade. Let's just upgrade 5 tokens. Right, we have this, looks like we just approved that. I'll wait a second here while this approves, and I'm going to switch back to the address that I've been using for the rest of this tutorial. Now let's go in and let's go in and upgrade those 5 super tokens. So if I click to upgrade, we're upgrading. So take 1 second here. All right, fantastic. We have upgraded the transaction. We can see this on Etherscan if we want. This will take a second to propagate. However, if we go to the Superfluid dashboard, we can see we just wrapped 5 DAI, right? So calling upgrade will wrap. If you want to downgrade, if I go back to our docs, we can go down to the downgrade version. I can very easily downgrade. I don't have to call the approval because I'm not directly working with any ERC20 asset, right? I'm working with the super token asset, and I can just call downgrade to unwrap my tokens, right? We have the same pattern here, right, where we're downgrading. We have this downgrade operation, and then we're broadcasting it. Let's downgrade those same 5 tokens. All right, fantastic. Same thing, we can see the transaction on Etherscan. And then in just a second here, we'll be able to see this in the Superfluid dashboard. All right, we can see that we've unwrapped 5 DAI. Now, in this example that we're providing you, these are not your tokens, right? These are all just fake tokens that exist inside of this massive test account, right, that we top up on a regular basis. In order to actually interact with your own tokens, you'll have to actually have the DAI in your wallet, so keep that in mind. When you're doing these upgrade and downgrade operations, this is not your money, this is fake fake money that is being used for the sake of demonstration. Okay, so 2 more sections to go. The first of which is about batching transactions. So one very cool aspect of the Superfluid protocol is that you can batch transactions together if you want, and do things where you perform lots of operations and only broadcast a single transaction and pay gas one time within your app. So if you want to provide a really cool user experience where you do interesting things like upgrade a bunch of tokens and then create 5 streams at once in a single transaction, you can do that. Right, so here are all the internal calls you can batch together. You can do the approve operations on super token contracts, transfer operations, upgrade and downgrade. You can do call agreement, and call agreement is technically the internal call happening anytime you work with the Superfluid agreement. So anytime you call the IDA or the CFA, you're actually making a call agreement call. That's what it looks like under the hood. And then call app action is a bit beyond the scope of this section, but call app action lets you call any function on a super app. Right, if you want to learn more about super apps, I recommend going here, but that's also extremely powerful as well. So in this example, what we do is we provided just a really simple walkthrough on how to upgrade tokens and create a flow in the same transaction. So let's open up this sandbox. Now, one thing to note with batch calls is that you can't batch in operations that don't have to do with the Superfluid protocol into a batch call, right? So if you're going to call approve on an ERC20 contract, that has to be separate, and you'll have to probably do that elsewhere in your UX as well if you're building an application on Superfluid that uses batch calls. So if, for example, I want to run this operation where I'm upgrading and then creating, I first need to allow my user to approve the super token DAI contract to spend our ERC20 in order to upgrade it. So we can see here that I have this DAI approve logic that we just looked at a bit ago. Let's just approve, we'll do 50 tokens. I'll approve these tokens. We'll see here that this has now been broadcast to the network. Let's also upgrade those 50 tokens. Let's enter an Ethereum address. So I'll grab an Ethereum address real fast. Okay, I've got that address. And then what I can do is enter in a flow rate. Let's send $25 per month. And now that those tokens have been approved, I can use a batch call to make this upgrade and the create flow operation happen in the same transaction. Now under the hood, what's going on? Well, we have the same process here. We're creating a signer. We're also creating the DAI contract for the approve up here. And then inside this execute batch call function, we're taking in an upgrade amount, a recipient, and a flow rate from our front end. Same thing where we initialize and create the signer, all that good stuff. We're creating the super token contract here that we're going to work with. And then interestingly, in this example, what we're doing is we're just going to call a couple of functions on the super token contract itself. So you can use that in creating a flow. You can use that sf.cfav1.create flow method if you want. But you can also create a super token and make all of this token centric as well, where you just call create flow on the token contract directly. And in that situation, you don't actually need to pass in the token address because it's already implicit inside of that contract that you've already created. So in this case, this is just an example of another way to create a flow. Now, if you want to run a batch call, you can see that I have this new operation here where I have await sf.batch call. And in order to initiate a batch call, what you do is you, in parentheses there, when you're passing your arguments for the function, you'll pass in an array, which is just a list of all of the different operations you'd like to perform. So you'll need to create the transaction objects here, assign them to variables that lets you know that what operation they are, list them here in this array, and then in my case, broadcast them to the network using this .exec functionality, right? So if we run this, okay, it looks like, see, this is actually a good lesson here. Now we have, if you get a cannot estimate gas error, it's always sometimes frustrating because you don't really know what happened. A common reason for that is if you either used an incorrect address for the token you're using, or if you tried to create a flow that already exists. In my case, that's absolutely what I'm doing. I tried to create a flow that already exists. We can see this exists here. If I try to create a flow again, it's not going to work, so let me cancel this first. Alrighty, we'll let that cancel. All right, that transaction has been canceled. Let's go back in here and we'll run it again. Now it should work. All right, fantastic. Here we go. We're mind blown because you just completed 2 operations in a single transaction. So I'm going to open it up on Etherscan. All right, and then I'm going to go back to the Superfluid Dashboard. All right, we can see here at 9:18 a.m. what I did is I wrapped 50 die and I started streaming in the same minute, which is a sign that we did it in the same transaction. Let's check our transaction hash here. Sometimes it's a bit difficult. Let me just copy and paste my address into here. Okay, and now it took a second for Coven to, Coven Etherscan to propagate that, but we see here in our most recent transaction for our address, we have this weird method, right? This indicates to you that it is a batch call, right? You can reverse engineer it if you want, like some aficionados in our community do, but we can see here that this was successful. So the final thing I want to go through is how to actually get data, right? So if we want to get data using the SDK, we can use either some predefined subgraph queries or just call methods directly on the CFA or IDA methods. So if I want to get the data from the predefined subgraph queries, again, we can go through the same process of initializing the framework and all this good stuff, but we can also access these default methods here, right? So we can list all super tokens and then filter list indexes, list index subscriptions, list streams, list user interacted super tokens, list events, and then again you can filter, and then you also have control over the paging and the ordering. If you want to see an example of how this actually looks, we can query the list all super tokens. We can filter by whether or not they're listed, which just means is this token listed in the Superfluid Dashboard. We can handle paging here, the second parameter, and then we can handle ordering. So we can see here where the order direction is descending and we're ordering by created at block number. Okay, so that's one way to go about querying data. Again, you have the reference here inside the getting data section. And then you can also get data from agreements. So if it were me just starting and wanting simple data that's very connected with agreements, like getting an individual flow, I can just run these read operations on some of these methods directly. So if I want to get a flow, I can call get flow. I can also get account flow info and then get net flow. And get net flow, what it's going to do is just give me the overall inflow or outflow rate of an individual account. So if I'm sending out more tokens than I'm receiving, my net flow is going to be negative. And if I'm receiving more tokens than I'm sending out, it's going to be positive. You can do the same on the IDA. So you can get subscriptions and you can get index. Right, and pass in these parameters to get that data. And then you also have some super token read operations as well, which are very similar to what you're probably used to seeing with ERC20 read operations. So balance of, allowance, name, symbol, and total supply. Okay, so that's getting data. Again, that's fairly simple. This is very dependent on what your needs are, but our assumption is that you're going to need some data, so we've built those into the SDK for you as well. That's a wrap on the SDK. If you'd like to get into more Solidity, I'd suggest going into Solidity examples themselves. If you want to dive deeper into getting data, I'd suggest going into the subgraph section. We do have many more guides on these topics in depth. If you'd like to go in depth, you can feel free to read through those. But yeah, we'd love for you to make use of the SDK and let us know what you think. Provide feedback to me. You can reach out to me at Sam at superfluid.finance, or you can reach out to our team in Discord in the developers channel of our Discord. So hope to talk to you soon. Hope this is useful, and go build something cool on Superfluid.